organized by Advocate B.D. Hambalde Mahavidyalaya and IUPSC department of our college. Welcome to all the delegates. Okay. We are organized the national seminar recent trend in the green chemistry for the sustainable development. I express my sincere thanks first to our President Honorable Kishore Nana Hambalde and our Secretary Honorable Atul Kumar Mayor for the given permission and sanction approval to organize this online conference on the recent trend in the green chemistry for sustainable development. I also sincere thanks for our principal Honorable Dr. S.R. Nimbore sir to support all the time to our department and to organize this given permission to this seminar. I welcome to resource person. This resource person is a very honorable Dr. Bhimraj Gaude sir from the Department of Chemistry, Anandrao Dhonde alias Babaji Mahavidyalaya Kada. He has published 25 national and international research paper and 5 books. He is the author of 5 books and he is one of the most big achievement in the research. He has published 4 patent and 3 patent is under consideration in the procedure. So this is a very good researcher we are getting for this national webinar. Okay. He is also under guide of the research chemistry. Thank you, sir, for your kind support and regular help to us. I request to you, please present the topic and continue our seminar and guide to all the researcher and our student also. Sir, please continue. Hello. Sir, please start. Please start session.
Gowde sir, you are not audible. Gowde sir, you are not audible yet.
Yes, sir.
Okay.
हाँ सर येतोय आवाज आता.
Yes, yes.
Good morning, one and all. I first thankful to the respected principal, Dr. S.R. Nimbure sir, HOD, Depth of the Chemistry, Master Amal Dongre sir, and IQSC cell coordinators and other staff members of Advocate B.D. Hambarde Mahavidyalaya, Asti, for giving me an opportunity for acts as an resource person for the technical session in one day national conference on recent trends in green chemistry for sustainable development. Uh, we also welcome again one and all delegate participants, students, staff members, and other supportive staff members in this one day national conference. Now I am Dr. B.N. Gaude, working as Assistant Professor in Department of Chemistry at Anandrao Dhonde alias Babaji Mahavidyalaya Kada. Now in this conference, I am here present in my lecture on the recent trends in chemistry, green chemistry for sustainable development. See here in this green chemistry, we have to use the word green, but actually this word is not for the green color. Now in the field of the chemistry, we have to prepare some chemicals or molecules that are utilized in the everyday life of the human beings worldwide. Therefore, this green chemistry is deals with the preparation or synthesis of the molecule in the form of the product. At that time, there is no hazardous chemicals or waste product is produced during the process of the reaction or the generally transformation of the material from one form to the another form. Now, in generally for in the sustainable development, what is the role of that green chemistry? And by using the principal green chemistry theme, we have to do the sustainable development of the society, also nation, and all other things. Now, I am here outline my presentation in the this various point. Now, how this chemistry and society correlate to each other, and we get the green chemistry benefit to us. Then again, chemical disaster. In the chemical disaster, how this green chemistry plays an important role to maintain or generally disaster happens during the chemical case. At that time, how we have to here take the precaution or how will you generally find out the various type of the solutions and here preserve or generally care the human beings or the biodiversity. And again, we have to see the history of the green chemistry. How this history of the green, the history of the green chemistry. How will you here procedurally means how this green chemistry is developed in the field of the chemistry era. Then how the concept of the green chemistry is modified or generally definition or all the this concept is developed in the way of the researchers, then some of the societies or those who are working in the field of the chemistry. Then globally, how this green chemistry is recognized in the worldwide in different countries, and they give the supportive progress to the green chemistry world. Again, green chemistry and sustainable development, how they relate to each other, and sustainable development is carried out by using the green chemistry field. 12 principles we have to also use to in the green chemistry for the development of the various field in the global. Then how will you do the progress in the green chemistry real world cases? I'm taking here for the representative example. And at last, finally, concluding remark means how we can use the green chemistry, and conclude in concluding remark, what type of the precaution, what type of the generally care we have to take for the sustainable development when we have to use the chemistry. Then see the first one is the chemistry and society, how they correlate to each other, and in everyday lifestyle of the human beings, we have to use the chemicals and different type of the product which is formed by the chemical material, and how this society is used that chemical by using these chemicals. There is some hazardous material, then waste material, and those materials becomes hazardous to the environment and crop also. Therefore, how they relate to each other in the form of the pharmaceutical area. In manufacturing process, some of the drug that are prepared in the pharmaceutical area. At that time, what happened? We have to prepare the some painkillers, antibiotics, hearts and hypertensive drug, or generally tonic type of the drug or other drug. When this type of the drug we have to synthesis or manufacture in pharmaceutical field, at that time, what happened? In that case, some of the product which is formed in the form of the byproduct, that product we have to reuse, but some product we cannot be used due to this product becomes the hazardous or useless, and therefore this type of the practice or generally this type of the product formation is not good for human beings or the society. Then in agriculture field, there is the production of the some of the fertilizers, pesticides, insecticides, and by producing this type of the product in the agricultural field. Now fertilizer we have to use, therefore there is the that affect the quality of the soil or generally health of the soil. Then some of the pesticides that also means there is the extra use that becomes the hazardous to the agriculture food. Then in the form of the food we have to use the some chemicals. In that case manufacturing of the preservatives that are used for the preserve the various type of the food. Then packaging and food wraps, then refrigerant that are used here, and from that some of the compound that used in the form of the food that can be becomes the hazardous to the society. Therefore, we have to prepare those compounds which are suitable that cannot be affect on the human beings or the society. For that purpose, we have to here this green chemistry term is used. In the medical field, some of the disinfectant we have to prepare, then vaccine is prepared, dental fillings is prepared, then anesthetics, contraceptive, then medical field. This type of the chemical compound that are used for the preparation of this type of the various component. And from that, we have to here these chemicals suppose here is the some of the disinfectants we have to use that disinfectant is mixed in the generally soil or water, and therefore this soil or waters become the polluted. Therefore this society and generally here chemically correlate this in the medical field also. In transportation there is the production of the petrol and diesel. Means here we require petrol and diesel. This petrol and diesel also chemicals, means these are the hydrocarbon, and in the catalytic converters to reduce the exhaust emission. By using catalytic converter in the petrol and diesel, therefore that reduce means catalyst use for this purpose that can be reduced the exhaust emissions, means there is the some of the other product that produce during the this process at that time that here minimize by using this one. Now in clothing means we have to prepare here produce the cloth at that time some of the chemicals in the form of the synthetic fiber, dyes, waterproofing material that are used, and generally most of the time we have to use this type of the material in the society. And when some are society parts environment that contribute us to the environment also. Polycarbonate the crash helmets to prepare by using the various chemicals. Then in sports, composite material for rocket, all here that whether surfaces that are prepared by using the different chemicals. Again, here is the safety sport material. Safety material is polycarbonate crash helmet we have to use. Then in sport, composite material for rocket, all weather surfaces that are used by using the chemicals, and this also here related. Means here different type of the material that are used that can be various type of the chemical that include in the chemistry. So, in office to prepare spaces were used or understanding the green chemistry concept. Now another point out is here, this is the chemical disaster. how this chemical disaster is takes place or some of the example in past that happened in the due to the chemical splitting or chemical mishandling. In 1956, Minamata disease was first discovered in Minamata city in Japan, and that disease is caused due to the release of the methyl mercury in the industrial wastewater from the chemical factory. In Japan, 1956, here in Minamata city, there is the release of methyl mercury from by in the industrial wastage in the water, and due to the mixing of this methyl mercury in the water, therefore that affect the society that living around to the this area, and therefore this cause the Minamata type of the disease. In 1961, Itai type of the disease was caused due to the cadmium poisoning due to the mining in the Toma prefecture in Japan. जे काही जपानचे मायनिंग आहे, इन मायनिंग देर इज द cadmium poisoning takes place, and due to this cadmium is also metal, and that also comes under the chemicals. Therefore this chemical poisoning takes place, and we get the etai type of the disease. In 1976, the Seoso disaster was an industrial accident that occurred in a small chemical manufacturing plant near the Milan in Italy. In Italy, 1976, there is happens, and in that also called as Seoso disaster, and therefore it result in the highest known exposure. What happened in that time? 2378 tetrachlorodibenzo paradioxine is a residence in the population. Now this chemical is spilled, means industrial accidents happens, and therefore near the manufacturing plant, chemical manufacturing plant, and therefore this chemicals becomes the here say also disaster, and that affect the living beings that present around this Milan in Italy. Industrial catastrophe that took place in a pesticides that owned with the operated by the Union Carbide in the Bhopal industry in India, resulting in the exposure of the here.
गावडे सर तुमचा माईक बंद झालाय. हॅलो 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 सर आवाज येतोय. माईक बंद झालाय तुमचा. प्रेझेंटेशनचा काही प्रॉब्लेम नाही आहे. हां येतोय आता आवाज. ओके.
हा ठीक आहे. हो हॅलो. Now, see another disaster that happened during the in past decade. In 1986, the Chernobyl disaster that takes place, and that Chernobyl disaster was a nuclear accident at the Chernobyl nuclear plant in Ukraine. Therefore, it resulted severe release of the radioactive material. Most of the fatalities from the accident were caused by the radiations poisoning. Means in Chernobyl there is the Ukraine nuclear in Ukraine, Chernobyl disaster takes place. In Chernobyl, nuclear plant is present, and from that plant, there is the radioactive radiations release from the radioactive material, and therefore this is called as the industrial in 1999, Exxon was an oil tanker hit and seized helium, a 10.8 million US gallon, that is 40.9 million liters of the crude oil in the recorded one of the largest spill in the United Nations history and one of the largest ecological disorder. This is the Exxon Weldon oil disaster that happens in the 1989. Another one, now in last we have to see the correlations of the chemistry as well as society. Then we have to also see the chemical disaster that's happened in the past, and now see here the green chemistry and their history, how this green chemistry is developed, and what type of the background that are present in behind the green chemistry work. In 1990, the Population Prevention Acts passed in the United States. In this help in a create that is the modus of operandi for the dealing with the population in an original, innovative way. This paved the way to the green chemistry concept. Means in 1990, Pollution Prevention Act takes place, and at that time, what happened? Passed in the United States. In United States, 1990 Pollution Prevention Acts here was passing. At that time, what is the act to coin or here? This generally acts as a help to create modus operandi for dealing the pollution in an original and innovative way. जे काही pollution that here modus operandi for the dealing with the pollution in the original and innovative way. Original innovative way ना जे pollution this pollution से modus करायचं आहे. Then in Paul Anastal and John Werner coined the two-letter word green chemistry and developed the 12 principle of the green chemistry. Now these are these two scientists, Anastas and Werner. This coined some of the words as a green chemistry, and for development of this green chemistry, they also here design the 12 principle. By using this 12 principle, to do your work under the term that is the green chemistry. In 2005, Ryoji Newari identified the three key developments in the green chemistry: use of the supercritical carbon dioxide. Now we have to see here supercritical carbon dioxide means that carbon dioxide here generally used as a solvent for the synthesis or transformation of the chemical material in one form to the another material. Now we know, or generally all of you know, the carbon dioxide is the hazardous to the society, and therefore here supercritical carbon dioxide means here is in the form of the fluid. That carbon dioxide is used as a green solvent for the synthesis of the various type of the chemical reaction. Then generally we have to use also aqueous hydrogen peroxide for clean oxidant. Aqueous hydrogen peroxide as a clean oxidant we have to use, and also we have to hydrogen in the asymmetric synthesis of the chemical reactions, or generally organic chemical reactions, asymmetric synthesis process. We have to use the hydrogen, means there is no loss of the other hazardous product that takes place during the process or generally production or synthesis of the reactions. Now these are the some point out history of the green chemistry, how this developed. Means in 1990 there is the Pollution Prevention Acts pass away in USA. At that time they create modus operandi for dealing the pollution in original and innovative way. Pollution prevent do the prevention or generally minimize the pollution. They here original and innovative way, there is the modus operandi which is designed. In Anastan and Werner, new concept developing there, that is the green chemistry, and also develop the 12 principle for the modification or generally development under the green chemistry. And then Rios Noyori in 2005, they use the here these three solvent for the synthesis of the various type of the compound. Means there is the greener route for the synthesis of the organic or generally chemical compound. Then see the concept of green chemistry. How this green chemistry have to means today's aim of your conference is the green chemistry for the sustainable development. In last two six slide we have to see the how this chemical or chemistry that deals with the society, and society also deals with the chemistry field. But we have to use or generally meet the daily needs of the human beings or the society. We require the use of the various type of the chemical material and their product. At that time, what happened? Some of the mishandling or there is the misuse of the chemical material or reactions or generally transformation or any other field. What happened? There is the mishandling takes place, and due to that, this becomes the hazardous to the society, human beings, then biodiversity, and that affect loss of some of the uh, generative materials. Means there is the generally biodiversity human beings or some of the disease takes place, this type of the here acting takes place. And then see the concept of the green chemistry, how this green chemistry is coin. Now green chemistry or sustainable environmentally begins chemistry. Means this is the green chemistry sustainable environmentally begins chemistry in the design of chemical product and process that reduce or eliminate the use of and generation of a hazardous substance. What happened in that case? Means how we have to here understood the concept of green chemistry. In that green chemistry means when we have to obtain chemical or chemistry, at that time what we have to do, first we have to remember when one form of compound is transferred to another compound, at that time we have to say this compound or there is a 100% conversion of one form to the another form, or generally there is a transformation of the all the reactant molecule to the product molecule. Means there is a no hazardous compound or the energy or there is the any byproduct that generally produced during the process or during the production or synthesis of the reactions. Means see here greener route for the synthesis of the chemistry we have to choice, and by using this route we have to here preserve means your energy, therefore your money also, and then your society also. Means there is the no affection takes place or generally effect takes place due to the use of the chemistry on the society, environment, and other things. Now similarly this green chemistry we have to use the for the sustainable development. In development we have to do the development, but at that time there is the some effective problems that cannot be created during that process. Therefore green chemistry is also one of the better way to here in the field of the sustainable development of the society, and therefore this green chemistry also helpful. In this way, similarly to sustainable chemistry or circular chemistry, generally this also called as a circular chemistry. There is the circle is completed once from the your reactant molecule, where again comes to the that reactant molecules. Means there is a transformation of the one form to the another form to next form, and therefore again recover the original your compound. Therefore this type of the chemistry also called as a circular or green chemistry. And then is an area of chemistry and chemical engineering focus on the design of product. Now this circular or sustainable chemistry or green chemistry, this is a area of chemistry or chemist or chemical engineering that focus on the design of product and process. That process or that minimize, eliminate, use and generate hazardous substances. What we have to do, there is process they to minimize or eliminate the use and generate hazardous substances. The eliminate use and generate hazardous substances to using this concept required change your product, design your product on there is no more use that can be here generally produced during process. And there are a lot of things which are to chemistry, inorganic chemistry, in branches of chemistry by using the chemical of the green chemistry means this new concept of the green chemistry is applies to the organic chemistry. In organic chemistry there is some of the reactions. At time what happen one reaction or one reactant molecule is transferred to the another one and here what we have to see means there is the transformation of one chemical compound to the another compound. Therefore, we have to choose the greener route or green chemistry route, and by using this green chemistry route, we have to do your process. In inorganic chemistry also, then in biochemistry, analytical chemistry, and physical chemistry, we have to choose your greener route. Those becomes prepare easier, not becomes hazardous to the environment and other things. Therefore, we can use this one. Means here generally we have to remember that where in the process of the chemistry or chemical reactions or chemical field, there is the minimum waste we have to produce, energy use, resource use, therefore minimize all these things in the process of this transformation or conversion. Then utilize the renewable sources. Those sources which are renewable, we can utilize that type of the sources during the process. And by using this concept, we have to do the sustainable development of the society. Now, this is the concept of the green chemistry. Then globally, how this globally green chemistry is recognized in the different country of the world. In Australia, the Royal Australian Chemical Society present Australia's Green Chemistry Challenge Awards. Then in Canada, the Canadian Green Chemistry Medals is an annual awards given to any individual or group for the promotion and development of the green chemistry. In Italy, green chemistry activities in Italy centers and in inter-university consortium known as INCA, in 1990, INCA has given 3 awards annually to the industry for the application of the green chemistry. In Japan, the Green and Sustainable Chemistry Network formed in 1999 in an organization consisting of the representative from the chemical manufacturers and researchers. In UK, in the United Kingdom, there is the Crystal Faraday Partnership non-profit group of the found in 2001 award the business annually for the incorporation of the green chemistry. In USA, United States Environmental Protection Acts, they pass here. In this Nobel Prize for the here development of the metathesis method in the organic synthesis. Now, this is the one of the greatest achievement in the green chemistry field. By using this green chemistry, we have to globally recognize by the different country, and at last, finally, one of the Nobel Prize in this field also get by the scientist. Now see this green chemistry and sustainable development. Now this is the main theme of your or our conference. Today we have to join together us. Now here the United Nations defines sustainable development as a meeting the needs of present without compromising the ability of future generations. See this statement here in sustainable development, meeting the need of present means here presently the needs of the society, community, or world have to meet today. At that time, what we have to commitment takes place without compromising the ability of future generation. Without compromising ability, future generation ability, not here generally without compromising. Therefore, green chemistry focus on how to achieve sustainability through the science and technology. Now, this green chemistry also focus or here some of the recent trends under the green chemistry to achieve sustainability through the science and technology. By using science and technology, how this green chemistry is achieve sustainable development in the society. For that purpose, what type of precaution, what type of the practices we have to do during this development. To better understand and solve the issues of environment pollution, many approaches and models have been developed for environmental impact assessment. First job, our job is that there is the some of the issues that solve environment pollutions, many approaches, models. We have to develop for environmental impact assessment. What type of the environmental impact that takes place? Therefore, we require to develop by using science and technology some of the approaches, many approaches and models that can assess the environmental impact on the society or development. Then some of these approaches and models have been successfully in predicting the impact of selected chemicals in selected environmental settings. Means for example, some of the here gases poisoning generally splitting takes place. At that time, those gases which are useful to the biodiversity that can be better, but some of the gases that can be hazardous to the human beings or diversity. Therefore, we have to some model that here prepare and selected chemicals or selected environmental settings. Means there is a splitting of the some chemicals in the environment. Therefore, we have to prepare the model or some of the approaches and that can uh, here generally identify the what type of the chemical or reduce their quantity by using this model whenever there is the some of the accident or generally splitting generally takes place. Therefore, these models have joined air and water quality aspect to point and non-point sources and have been very useful for the development of the emission control and compliance strategies. And some of these model we have to join air and water quality aspect. Out of this model, we have means mainly some of the air because in any type of the transformation or chemical reaction takes place. These two material factor that is air and water mostly that affect by using this type of the practices. Therefore, we require to develop such a type of the model that join air and water quality aspect to point and non-point sources. The point and non-point sources, those produce the generally quality of the this factor, and then have been very useful for the development of emission control. Means these models here are useful for the development of emission control and compliance strategies. compliance strategies and emission control. This model we have to use for that one. Then however, some of the approaches that are here and models, we aim primarily at the evaluating the quantity of the pollutant that could be discharged into the environment with acceptable impact, but failed to focus on the population prevention. Now see here, some of the models or approaches which is coined under the science and technology. But what happen here? Some of the that can be acceptable means that can be used or that gives the good result by using this. But this model generally here affect or fails focus on the there is the population prevention. Means green chemistry there is the some of the chemicals or generally drug molecule that are prepared and that here use for the prevention of the better health and from that purpose they cannot be generally here stop or generally prevent the pollution prevention. Then the concept of the end of the pipe approaches to waste management decrease and strategies such as the environmentally conscious manufacturing, eco efficient production or pollution prevention gain recognition. Some of the concept end of the pipe approaches to the waste management decrease means one of the we have to take the one of the example of the industrial process. In industry there is the some of the wastage material that are here that are released in the water sources or generally open spaces. Therefore, we require to here design the some of the model or approaches, and from that we have to from the end means at the end waste management decrease end we have to use that type of and then strategies such as the environmentally conscious manufacturing, eco-efficient productions means there is the ecologically means environmentally, ecologically, biodiversity, profitable production is required, and then pollution prevention gain recognition. Pollution prevention means there is the prevent the pollutions means those material which is become the hazardous to the environment. Therefore, we have to prevent by using this model and approaches which is coined by using the science and technology under the term of the green chemistry, and therefore we get the here the development or we do your development in future development by using this one. Therefore, this is the some of the way to develop the sustainable development, and in that we have to use the recent trends generally green chemistry approaches for the development. This is the smallest or this is the one of the way of the green chemistry because more in urbanization or development process there is some other factors also affect, but in that case, we have to consider in the chemical way or in the chemistry field. This chemical field use the green chemistry word, and by using this green chemistry, we have to do this type of the practices. Then there are the some of the 12 principle which is designed by the researchers. In that first one is the prevention. Now this is the in preventions means what we have to do during the chemical handling or transformation of the chemical material. We have to prevent or prevention means there is the it is the better prevent waste than to create or clean of waste after it is formed. Means the preventions means there is the design your process or the root of the synthesis of the reactions that can prevent or there is a no wastage or no hazardous compound that are formed after the completion of the reactions. Then in atom economy, in that in the synthetic method should be the design to maximize the incorporation of all material used on the process into the final product. In atom economy is there is the in the synthetic method in the reactant side and in the product side. In reactant side, whatever the atom that are present in the reactant molecule that also transfer to the product means 100% atom economy is required for this process means these are the principle that are comes under the green chemistry. First one is your prevention means there is the formation prevent the hazardous material formation. Second one is the atom economy. In atom economy means there is the 100% conversion of your reactant molecule to the product molecule. Then we also less hazardous chemical synthesis means we also take the care of the synthesis of the chemicals less hazardous or those not hazardous. This type of the chemical we have to synthesize. Wherever practicable, synthetic methodologies should be designed to use and generate the substances that possess little or no toxicity to human health and the environment. Now, this is here the some of the less hazardous chemicals we have to synthesize. Then designing the safer chemical product should be designed to preserve efficiency of the functions while reducing the toxicity. Then safer solvent and some of the auxiliaries, the use of the auxiliary substances, for example, solvent. Then a separation agent should be made the necessary that is the wherever possible and innocence when they are used means see these are the prevention atomic economy less hazardous chemical synthesis designing safer chemicals safer solvents and auxiliaries. These are the principles of the green chemistry we have to use. Then design for the every efficiency, the use of the auxiliary substances, for example, solvent, separation agent, should be made necessary. That is wherever possible and innovation when they are used. Means we have to design process for the energy efficiency. Use auxiliary substances, solvent, separation agent should be the made unnecessary possible and inconvenient when they are used. Use of the renewables feedstock energy requirement should be recognized for their environmental and economic impact and should be minimized. Synthetic methods should be conducted at ambient and temperature process. Means this 6 number that is the principle of the green chemistry design the for energy efficiency. Energy efficiency design the process. Then use of renewable feedstock. Renewable feedstock that are present, then we can use that one. Energy requirement should be recognized for their environmental and economic impact should be minimized. Synthetic method should be conducted at ambient and temperature and pressure. Then reduce the derivatives. Raw material or feedstock should be renewable rather than the depleting wherever technically and economically practicable. Means here is the reduce the derivative. Whatever derivative that are present or those compound is present, we can reduce that derivative by using the greener route of the chemical process. And we also use the catalyst, reduce the derivative, unnecessary derivation blocking group, protection, deprotection, temporary modification should be avoided whenever possible. Catalytic reagent as a selective as a possible and are superior to the stoichiometric reagent. Now see here, this is the these are the some 9 principles for the synthesis of the green chemistry process or use of the green chemistry in the synthesis chemistry. Then 10th number, design for degradation. Some of the molecule or process or chemical product that are formed during the reactions or chemical process, they can be degradable easily or biodegradable compound should be designed. In chemical product should be designed so that at the end of their function they do not proceed in the environment and break down into the innocuous degradation product. Then 11th number principle of the green chemistry, real-time analysis for pollution prevention. Means there is the pollution takes place, therefore do the real-time the analysis and prevent that pollution. Analytical methodologies needs to be the developed to allow real-time in process monitoring and control the prior to the formation of hazardous substances. Then last principle or 12th principle of this green chemistry, inherently safer chemistry for accident prevention. We have to inherently safer chemical use for the accident prevention. Substances and the form of the substance used in a chemical process should be chosen to minimize potential for chemical accident, including the release, explosion, and fires. See here, these are the 12 principle of the chemistry. By using this 12 principle, we have to use the green chemistry for the sustainable development. See again here, prevention, atom economy, less hazardous chemical synthesis, then design safer chemical, safer solvent, auxiliaries that can be used in the field of the chemistry. Then design for the energy efficiency, use of renewable speed stop, reduce the derivatives, catalysis process we can use for the during the transformation of the this material. Then design for the degradation, some of the process or the chemical product that can be designed whenever they are useless at that time they can be easily degradable and that cannot be becomes the hazardous to the society. Then real time analysis for the pollution prevention, then inherently safer chemistry for the accident preventions. Means all these 12 principles tell us that means those activities that becomes the hazardous to the society, environment, biodiversity. Therefore, this type of the activity we have to avoid, and there is the choice of the new or better route for the transformation of the material in the form of the chemistry, and therefore that can be here used for the sustainable development purpose. Then how this green chemistry progress in the real world cases, means how this green chemistry now this in previously we have to see some of the background cases of the green chemistry, and now how this green chemistry is progress in real world cases. Over the past decade, green chemistry has convincingly demonstrated how the fundamental scientific methodologies can be devised and applied to protect human health and environment in an economically beneficial manner. Means main aim of the this use of the green chemistry means what we have to those process or chemical using practices that cannot be become the hazardous to the environment, or they can also economically beneficial to the society. Then significant process has been made in the key research area such as atom economy, alternative synthetic route for the feedstock, starting material, biocatalysis, green solvent we have to use, biosorption, this type of the method we have to use for the transformation of the chemical material or use of the part. Then designing safer chemicals, energy and waste management. See, we have to some of the research area or for the development purpose, we have to remember that type of the practices and significantly progress we have to did in this area through the researchers or research area for the development of the society. Uh, then see in that we have to see the first singleton for the atom economy. Now this atom economy in that synthesis of the propane, for example in the organic synthesis, uh, One of the compound is I am taking ibuprofen is a drug molecule, but I am generally one of the example is taking as a transformation of the ethene to ethane. Here ibuprofen drug molecule. In that case, we have to use the your reactant molecule, and once the reactant molecule is transferred to the product molecule, at that time there is the 100% transfer means conversion of the initial reactant atom to the product atom. This is the better example of the synthesis of the ibuprofen in the medical field. Now we have to take the another general example in atom economy or simple example. One of the fundamental principle of the green chemistry, atom economy looks at the number of atom in the reactant that end up in the final product and byproduct or wastage. Percentage atom economy is equal to 100 into relative molecular mass of the product divided by relative molecular mass of the reactant. बघा यामध्ये 100 percentage atom economy. Suppose here is the relative molecular mass of the product is 1, relative molecular mass of the reactant is 1, means both the molecule in the product and reactant side molecular mass is same. At that time this ratio becomes the 1 into 100 means 100% atom economy takes place. See, this is the one of the example when we have to transfer ethene molecule to the ethane. Now this is the simple reactions. At that time here is the double bond present in the carbon carbon in the ethene. When this stated with the hydrogen molecule, now see here this carbon double bond carbon here one for this or on this carbon there is two hydrogen is attached, on this carbon also two hydrogen attached, and this carbon is bonded to this carbon by the double bond. Means here there is the presence of these two carbon, this one and this 2 3 and 4 hydrogen atom. When these molecule means this ethene molecule react with the one molecule of the hydrogen, what happens? One hydrogen atom, this is hydrogen molecule attached to this carbon, another atom attached to this carbon, and therefore there is the formation of your ethane molecule. What happened in this reaction? We require the atom economy. Means in this molecule there is the presence of the two carbon, this 4 hydrogen and this 2 hydrogen, means there is the presence of the 6 hydrogen. And in the product molecule means the ethane molecule, there is again presence of the 2 carbon and here is the 6 hydrogen. Therefore, there is a 100% transformation of your reactant molecule to the product molecule, means we get the 100% atom economy. We have to try or develop synthetic route out of the process that gives this type of the economy during the transformation of the chemicals. Then another alternative synthetic route for the feedstock and starting material. See here another example, production of the dimethyl carbonate production. In that case, traditional method for the production of this is used. Means generally dimethyl carbonate is a versatile and environmentally inconscious material for the chemical industry owing to its high oxygen content and bleeding properties. Now it is used as a component of the fuel. Means the dimethyl carbonate used as a component of the fuel. Traditional method for the production of this dimethyl carbonate, whenever this is the dichlorocarbonyl that react with the methyl alcohol molecule and we get this DMC compound with the loss of the two molecule of the HCl. We know that this dichlorocarbonyl also hazardous compound that react with the greener compound, that is the alcohol compound that is not hazardous. Therefore this react together, we get the formation of the DMC plus acid molecule, two molecules of the acid. Now this acid is the hazardous and therefore this type of the avoid the synthesis of this type of the compound by using the traditional method. Then in alternative method, we have to use the production of dimethyl carbonate. Now in this case, copper chloride used as a catalyst, methanol and oxygen and carbon monoxide. Now see here, this copper chloride, methyl alcohol and here is the oxygen react together, we get the formation of this compound. And there is the one water molecule is the byproduct. Therefore, we know this water is the not hazardous to the environment. Then again, this compound react with the carbon monoxide, and there is the again recovery of the copper chloride plus your DMC compound. Means there is the no loss of the or hazardous compound takes place. Means this is the alternative route or the production of the DMC is the better or greener route. Therefore, green chemistry is also tells us that we have to choose your alternative route, those route which is help to the environment, well to the society during the sustainable development of the society. Now this is the one of the representative example. Then we have to use the biocatalyst. Some of the biocatalyst also present in the on the earth, and that using biocatalyst we have to do the chemical process. So for example, here is the bioleaching is the extraction of the specific metals from their ores through the use of the microorganism such as a bacteria. In this case, this is a much cleaner than the traditional heat and leaching using the cyanide in the case of the gold extraction. Now, some of the metals that can be extracted by using the ore in the mines, at that time bioleaching process we have to use and extract that material, means there is a no extra hazardous material is formed. Then extraction of the gold takes place at that time. In now this can involve numerous ferrous and sulfur oxidizing bacteria such as acid thiobacillus ferrodoxidant and acid thiobacillus thioxidants, and that referred to as that is the thiobacillus. And this bacteria catalyze the breakdown of the mineral arsenopyrite, then by oxidizing the sulfur and metal in the case of the arsenic ion to the higher oxidation. Means we have to, for the extraction of this type of the gold ore, we can use the this bioleaching process, and by using this biolysis process avoid the formation of the hazardous compound. Now see here, this is the FeASS, that is the here arsenopyrite, and under this bioleaching process, this Fe2 plus AS3 plus and this separation takes place in the form of the aqueous material. There is no production of the hazardous material. This process occurs in the cell membrane of the bacteria, and therefore electron pass into the cell and are used in the biochemical process to produce the energy for the bacteria to use the oxygen molecule to the water. In the second stage, bacteria oxidize Fe2 plus to the Fe3 plus. Wheels are reducing the O2 molecule. Then Fe2 plus transformation Fe3 plus, we have to see this type of the, means there is the oxidation takes place with the loss of the electron. Then they then oxidize the metal to give the higher possible oxidation state, and with the electron gain and reduce the Fe3 plus to Fe and continue the cycle. Gold is now separated from the ore and in the solution. Now, by using this extraction process, means bioleaching oxidation process, we can recycle the process, and gold is extracted by using this process, and therefore gold extraction takes place by using this bacteria. Then green solvent, one of the green solvent is a supercritical carbon dioxide is there. That supercritical carbon dioxide referred as a carbon dioxide, it is a fluid state, and also being at the above both in critical temperature and pressure. Here is the temperature 31.3 degrees Celsius, and critical pressure is 1071 Pascal or 72.9 atmosphere, yielding rather uncommon properties. Then supercritical carbon dioxide has been used in an processing solvent as a polymer applications and a polymer modification, then formation of the polymer composite, polymer bleeding, microcellular forming, and particle productions and the polymerization process. Therefore, we can use the this green solvent. For example, here is the reactions of ammonia with carbon dioxide. See here, this carbon ammonia is the primary amine react with carbon dioxide. We get this product, and here is the loss of this one. And by using this means greener solvent, critical carbon dioxide, supercritical carbon dioxide. Therefore, we get the formation of the polycarbonate without loss of the material. Means this carbon dioxide is the hazardous to the environment. When this transfer to the liquid state, this becomes the greener solvent, and therefore by using this carbon dioxide we have to do this type of the amination reactions, and we get the polycarbonate type of the compound. Then bioabsorption process in that important phenomenon which is based on one of the 12 principle of the green chemistry. I am taking only representative example for the use of the renewable resources, means this green chemistry, and that it has gathered as a great deals of the attention in recent year due to rise in environmental awareness and the consequent severity for the legislation regarding the removal of the toxic metals ions from the wastewater. Then in recent year, a number of agriculture materials such as the following have been used for the remove toxic metals from the wastewater. For example, palm kernel where husk we can use for the bioabsorption process. Then modified cellulosic material, corn cobs, residual lignin, wool, apple residue, olive meal product, then polymerized orange skin, banana husk, pine pack, then soda, coals, and maize tassel. These are the bioabsorption material that are used during the process of the chemical transformation. Then designing of the safer chemical. Last one is the here some of the safer chemical design, and by using this chemical we can also do the process of the transformation of the chemical from one form to the another. In that flame retardable chemical we have to prepare. In that, for example, flame retardable containing the bromine compared to chlorine and iodine shown to be the most effective and require the lower loading of the material. Then brominated flame retardant are structurally diverse group of the component, and are one of the here two example is present. Polybrominated diphenyl ether, then tetrabromo bisphenol type of the compound. Now this flame retardable compound we have to use. Then new flame retardable compound, that is the decabromo diphenylethane, then tribromophenolethane, then pentabromophene acrylate, tris tribromophenyl phosphate. This type of the compound we have to design that becomes the safer. Then energy, fossil fuel. This is the dog with the many environmental pollution problem. There is the throwing for the alternative energy sources to replace the fossil fuels. Renewable energy sources that are currently receiving the attention include the solar energy, wind energy, hydro energy, fuel cells to mention but four. Uh, Here we have to use the fossil fuel or the energy sources. Then we have to use the safer petrol, removal of the lead from the petrol. From the petrol, we have to remove the lead and use the safer petrol. Addition of the ethanol product for the biomaterial to the petrol pool. In petrol, we have to use the ethanol or the biomaterial for their production, means there is the loss of the some of the hazardous gases. Then addition of the methyl tertiary butyl ether and to the petrol pool, and MTPB, that is tertiary butyl methyl ether, has a high octane and that are used for the electric vehicles powered by the fuel cell. Then see, this is the trigonometric representation waste management how to control. Now in see here your traditional method for the control of the waste management is a disposal. Then energy recovery, recycling, reuse, then minimization, means your aim is to with those hazardous compound or material that form Therefore, that can be disposed, energy recovery, recycling, reuse, minimization, and last one is the better chemistry concept to prevent those hazardous compounds are formed from the chemical reactions. Therefore, we have to better way to prevent those compounds cannot be formed through the process means those which are become the hazardous to the environment and global. Now, least favorable option is here. That is the disposal. This is the traditional one. There is required the long time for disposal purpose. Energy recovery not possible to us, and therefore this one. Now, concluding remark, only 2 minutes. For last point is the concluding remark. The challenges in resources and environmental sustainable development require more efficient and begins the scientific technology for chemical process and manufacture of the product. Green chemistry addresses such challenge, opening wide and multi-phase research scope, thus allowing the invention of the novel reactions that can minimize the desired product and minimize the waste and byproduct, as well as the design of the new synthetic skin that are inherently environmentally and ecologically begins. Therefore, combining the principle of the sustainability concept as a broadly promoted by the green chemistry principles with the established cost and performance standard will be the continued area and economic for the chemical industry. Then it is also therefore essential to direct research and development effort toward the goal that will constitute a powerful tool for fostering the sustainable innovations. Green chemistry alone cannot solve the process environmentally concern and impact to our modern area, but applying the 12 principle of the green chemistry into practice will eventually help to pave the way toward where the grass is greener. And now these are the concluding remark of the our presentation of this act. Therefore, we have to think green, miss here, and thank you. Hello.
Hello. Hello. Hello.
हाँ बोला.
Okay. Hello.
हाँ बोला. Hello.
Thank you, sir.
Thank you, one and all of you. Thank you for giving me a chance as a resource person.
Thank you, Dr. Gowde, sir. You are giving very interactive session to our participant delegates and students and researchers. Thank you very much. Any student, any researcher having doubt on this topic, please ask to our expert. Any participant having any doubt? So please ask your our expert. I think no any doubt all the students and all the delegates. So thank you very much, sir. You are giving very detailed information on green chemistry in very simple language and explaining the various types of application of green chemistry, atom economy, green revolution, safer chemicals, decreases energy in the reactions, various types of the applications in the reactions in the green chemistry you are explaining. So very fruitful session for this. Fruitful session for this. Now I request our principal, honorable principal, Dr. S.R. Nimbore sir, for the complimentary close. Hello, sir.
Hello, can I audible?
Yes,
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 sir.
sir.
Thank you. गुड मॉर्निंग वन एंड ऑल. आष्टी तालुका शिक्षण प्रसारक मंडळ संचलित ॲडव्होकेट बी.डी. आंबेडे महाविद्यालय आष्टी organizing one-day national webinar on recent trends in green chemistry for sustainable development. The research person of the webinar is Dr. B.N. Gowde, Department of Chemistry, Anandrao Dhonde Mahavidyalay, Kada, is also a student. There are various innovations in green chemistry, renewable feedstock, use of plastic in experiments, and proper disposal of waste. Various application of green chemistry helpful for sustainable development. The new ideas in green chemistry are explained in a very simple language by Honorable Dr. Gowde from the Department of Chemistry, Honorable Golde Mahavidyalaya, Tada.
स्क्रीनशॉट मारून घ्यावा थोडे.
I am very happy to see Dr. Gowde speaking so
ज्यांना
authentic
काय ना तर
and important theme in a seminar as a resource person. All sciences work for betterment of mankind, but wrong use of may bring hazardous. Green chemistry is an idea to see positive side of chemicals and to control negative side of them. This type of collaborative activities will definitely help students and research scholars as well as day life. Again, organizing such a nice webinar on recent trends in green chemistry for sustainable development. Thank you very much.
थँक्यू सर. Thank you, sir, for your guidance and support to organize this collaborated activity of this webinar. Now I request to Professor Rayawat sir to propose the vote of thanks for this national webinar.
Thank you, sir. Firstly, I thankful our Samstha's President, Venerable Kishore Nana Hambore Sahib. He gives to arrange today's online webinar permission. So again, I will thank you to our Samstha's President. I express my deep gratitude to the resource person, Venerable Dr. Gowde sir, for very systematic guidance and useful information. I thank our President Dr. S.R. Nimore Sahib for chairing the session. I am very grateful to all delegates, professors, research scholars and students who were present online. I thank all my colleges for the teamwork. So thank you.
Thank you, sir. Thank you.
Thank you for all the participants, all the delegates. You are requested to fill the feedback. Feedback link will be shared on your group. Auto-generated certificate also issue you to register mail. So please fill your feedback form. And thank you for this interactive session, all the delegates and persons also. Thank you, all of you. फीडबॅकची लिंक दिली
फीडबॅकची लिंक तुला वैयक्तिक टाकली
मला टाकून